But let's get started. I'm Jennifer Brennan. I will be your host. Today, let's go ahead and, did I give people a couple more seconds on the poll? I think we're good. Okay, so I'm going to mute everybody at this particular time, okay? Okay, so we will get started here. Here's the agenda. For today, we will have a recap of yesterday's webinar with Jorge Vasquez, and we will then, that'll take about 5 minutes. For the next 15 minutes, Rosanna Sumagaisai Aweda will go over she'll give a brief overview of the primary data discovery and data access tools for sea surface temperature and other physical oceanography data sets available through PO.DAAC. The next section of the presentation today will be approximately 25 minutes, and we will, Rosanna will touch upon the 4 tools that are listed below here, and then we will finish with 4 polls, which should take about a minute or 2, and a 15-minute question and answer period at the end of the webinar. For those individuals who would like to stay on past that 15 minutes, you are welcome to do so. We will extend the question and answer period an additional 15 minutes, okay, past that. So with that, I will turn to Rosanna's presentation here.
Hi, this is Rosanna Sumagaisai. What I'm going to do right now is I'm going to pass the mic over to Jorge, who will give us a brief summary highlights of what was presented yesterday. So here's Dr. Jorge Vasquez.
Just briefly, I'd like to just summarize some of the key points from yesterday, from Ed Armstrong's presentation, from Michelle Garrick's presentation, and from my presentation. In terms of the overview of GHRSST, some of the key points are that GHRSST provides common data formats, in other words, interoperability. It also provides improved accuracy. It also provides data uncertainty characterizations for each SST pixel. This is a huge breakthrough. So each sea surface temperature that is provided by the GHRSST project has associated with it a complete error characterization as best we can do. That includes a bias and also a standard deviation. Every satellite sensor, nearly I should say every satellite sensor that measures sea surface temperature is represented in GHRSST in level 2P, level 3, or level 4 data set. And GHRSST is basically made up of an international task sharing framework that exists for both data production, distribution, and archive. For Michelle's presentation, just briefly, SST is commonly used to distinguish in basin scale features like El Nino, ENSO, with the El Nino Southern Oscillation, and it's used to distinguish events, the variability specifically in the equatorial Pacific. And SST also, and this is very critical, why is it even important? Why are we even talking about it? It's been declared as an essential climate variable. In terms of the coastal applications, SST is important in terms of understanding the dynamics of coastal regions, and associated in these coastal regions are major upwelling events. So this leads to a necessity of SST, especially in coastal regions that have high resolution, where you have these large changes in temperature along frontal structures in coastal areas and small-scale dynamics. So one of the main points that we wanted to bring out from these 3 presentations is when you ask the question, what GHRSST product that you want to use, you really have to look at the application as well as the characteristics of that GHRSST product, and both the interoperability of GHRSST and also the information associated with the different GHRSST products, the metadata, the CF standard, really allow you to do these things for the first time, I think, and it's a major breakthrough in how we do distribute data and data management. Thank you.
Okay, our next presenter is Rosanna Sumagaisai-Aweda, and she will begin her discussion of the physical oceanography data access and visualization tools. Rosanna?
Thank you, Jennifer. Hello, everyone. Thank you again for joining us today in this webinar. My name is Rosanna Sumagaisai-Aweda, very long, but doable to pronounce. I'm the lead for the Physical Oceanography Distributive Active Archive Center, User Services and Interfaces team, or simply PO.DAAC's USI team. Our team is responsible for all the interfaces to the user community, like our help desk, our web portal, deployment of off-the-shelf applications, and PO.DAAC developed tools and services. Prior to my current position, I've taken the roles in PO.DAAC as an archive systems engineer as well as a data engineer for sea surface temperature. I want to mention briefly that PO.DAAC is one of the 12 DAACs of the Earth Observing System Data and Information System, as this, for short, provides science data to a wide community of users for NASA's Science Mission Directorate. So here are the topics I will be going over today. First, to go over the characteristics of the GHRSST data products, followed by an overview of the tools and services we have here at the PO.DAAC. After that, I will do some live demos of selected tools. These tools were selected because they support all, if not most, of the GHRSST data sets in our data holding. So they either provide a way to search for GHRSST data from our data set discovery, or to retrieve via data access protocol that allows aggregating of data sets, subsetting, subsampling of files via OpenDAAP and threads, as well as to visualize level 4 gridded blended GHRSST data through live access server. So GHRSST data is available for free. All of the files are formatted in SCDF as well as CORD CF file level metadata compliant. The CF or climate and forecast metadata conventions describe how to encode ocean, atmosphere, climate data sets in SCDF, which addresses space and time coordinates, units, parameters, names, and so on. So of course, the strength of this type of packaging provides an enhanced level of interoperability to the data, where many powerful scientific software can read it. Now, this is a great advantage to our users, for they in turn can utilize these tools for their research, analysis, or validation of the data, and there's plenty of them out there that are for free. In addition, all of the files have corresponding GCMD diff metadata record, where GCMD is NASA's Global Change Master Directory that holds more than 28,000 Earth science data set and service descriptions, which covers subject areas within the Earth and environmental sciences. DIF stands for Directory Interchange Format and is used in GCMD to create directory entries which describes a group of data such as GHRSST. Also, FGDC metadata record compliant is applied where the information is produced at the NOAA National Oceanographic Data Center. NOAA NODC for short is the GHRSST Long-Term Stewardship and Reanalysis Facility. So the GHRSST data, in this slide, we describe its characteristics. There are 3 different processing levels, where level 2 has a satellite native swath projection. There are 29 level 2 data sets that have spatial resolutions ranging from 1 kilometer to 25 kilometer, and temporal range from the earliest 1997 to the present. The level 3 gridded data sets, either global or regional, there are 11 of these data sets that have spatial resolution ranging from 2 kilometer to 25 kilometer and temporal range as early as 1997 to the present. The temporal range will soon extend out to 1981 when Pathfinder GHRSST becomes available. The level 4 gridded blended data sets, either in global or regional, we have 21 of these data sets that have spatial resolutions ranging from 1 kilometer to 25 kilometer and temporal range coverages from 1981 to the present. So the GHRSST data are housed in 2 data centers. NASA JPL PO.DAAC is the GHRSST Global Data Assembly Center, or GDAC, where we have level 2 data within the 30 days of observation in rolling store for distribution. In addition, we have selected level 3 and all of level 4 that are archived and available for distribution. In partnership with NOAA NODC again, the center is the GHRSST Long-Term Stewardship and Reanalysis Facility. They distribute and archive all of the level 2, level 3, and level 4 data, including data older than 30 days. So here, the next slide, we identify the data challenges, where there are 61 data set that comes in various processing levels and projections, varying temporal ranges and varying spatial coverages. We also have user needs challenges where there's specific criteria associated to their studies, research and applied, to be applied for searching for their desired data. The desired data would either be global, regional in the case of Michelle's presentation yesterday on her ENSO studies, coastal for Jorge's presentation about understanding the dynamics of coastal regions associated with major upwelling along the coast of Peru. Then there are climate studies with another set of criteria for spatial resolution and temporal coverages. So with those challenges, we provide tools and services and hope to support in the finding and accessing of data based on users' data requirements. So this leads us to the overview of tools and services that we provide here at the PO.DAAC. This is a snapshot of our data discovery utilizing faceted search or navigation. This is a technique for accessing a collection of information represented using a faceted classification. In this case, the classification for oceanographic data, allowing users to explore by filtering available information, as you see here on the right side of the navigation. Applying the filters will narrow down your results, and I will give a demo on the usage of this shortly. The next slide, we have 3 types of direct data access. The first one is FTP, File Transfer Protocol, and it is the most popular method of access to our data. And one can use either the web browser for downloading, or if you're snazzy with Unix, you can use the Unix command line. The only disadvantage of this is that if you wanted to only get a subset of the data, you would actually have to download the entire data file. And so that would require you to have a fairly large amount of storage on your desktop. So the next, direct data access provide a solution where you can actually subset only a certain region for you to download. And this is via OpenDAAC. It's a data transport architecture and protocol based on FTP, and it's widely used in the earth science communities. It enables access to remote data sets through familiar data analysis and visualization packages like MATLAB, IDL, Ferret, NC Browse, Live Access servers, just as if they reside locally on the user's machine. So our OpenDAAC follows the same directory structure as our FTP, but only exposes our HDF and NetCDF files. So in here you can see one can drill down, to, select the ocean temperature, and as you drill down to a specific year day of a GHRSST data product, you can then click on that NetCDF file, and it comes back a data access form where you can visualize the variables for that particular data product, including the attributes for each variable and the global attributes for the data file. The third direct data access is Threads. It's a web server that provides metadata and data access for scientific data sets using data access protocols via OpenDAAC, WMS, WCS. These are web mapping services and web coverage services that are standards from the Open Geospatial Consortium. There are also viewers bundled in Threads, software such as IDV, which is an integrated data viewer, NetCDF Java tools, and Godiva 2. In addition to the features I already mentioned, we deployed Threads at the PO.DAAC for its ability to aggregate files into a virtual data set. For example, taking an entire time series of a data set and aggregating them by time into a virtual NetCDF file. So where the time variable becomes a new variable to the data set with values of time for each data file in the time series. So you're, in essence, you are actually seeing a virtual file, just one file that accesses the entire time series. And so here's an example snapshot of our catalog for our selected GHRSST data. These are catalogs that are configured in threads. When you select one, it opens up another URL where it provides you accesses to this virtual netcdf file as well as access to the viewers. When you select the OpenDAAC, which is the first data access, it's just like the normal OpenDAAC. They've also bundled this in their software. You can see that now that the time variable has more than one value because it is containing the entire time series. And the viewers also here, this is a snapshot of the netcdf NC view as well as, well, the Godiva I will show you in a moment. Our next suite of tools are the high-level access and visualization tools at the PO.DAAC. HiTide, which stands for High Level Tool for Interactive Data Extraction, is a web-based interface that does search, imaging, and extraction of Level 2 swath data. Currently, this tool supports only 3 Level 2 GHRSST data, which is the MODIS Aqua, MODIS Terra, and AMSR-E. An improved version of the HiTide is scheduled to be released sometime this summer in 2013, so we're hoping to be able to demo this tool in one of our future webinars. The Live Access Server is a free software similar to OpenDAAC and Threads that we deploy here at PO.DAAC. LAS was developed by NOAA PML. It is configured a web server that provides visualization, access to georeference data. Most of our Level 4 GHRSST data sets have been configured to be accessible via this tool. And I will be doing a demo on the LAS after this presentation. Lastly, our visualization tool, State of the Ocean, SOTO, provides near real-time data that gets displayed on Google Earth, Virtual Earth. You can do layering of parameters, SST over sea surface height anomaly, over wind vectors, ocean color, etc. This particular tool supports only one GHRSST data, and that is the level 4 blended 1 kilometer G1 SST. So now going back to the challenges that we have with GHRSST data and users' requirements, one would ask, there are so many GHRSST data sets, how do I decide which one to use? So users should ask themselves some basic questions. What spatial and temporal resolutions do I need? Do I need a skin or foundation bulk temperature? Do I need regularly gridded data with no data gaps? What temporal range do I need? Do I need near real-time data? Do I need level 2, etc.? So before a user dives into the passage, he should ask themselves some of those basic questions. Now referring back to the user scenarios from yesterday's presentation, before going into the demo, we will be using this scenario. The first scenario is Michelle's study on El Nino Southern Oscillation using GHRSST data sets in the equatorial Pacific Ocean. And her needs are that she needs long time period somewhere greater than 20 years, gridded, global, and foundation temperature. For the second scenario, and this is Jorge's application, which is the coastal, using GHRSST data set to understand the dynamics of coastal regions associated with upwelling and small dynamics. His needs are different. He wants high spatial resolution because he wants to see more regional areas. Long time period, maybe greater than 10 years within, gridded, blended, as well as foundation temperature. So now, based on the previous questions, the requirements are identified as below. We're going to switch over to the demo, And these are the data discovery. I'm going to demo the data discovery, OpenDAAC threads, and the live access server. And we're going to use those scenarios to drill down in the faceted search as well as samples on how to use these other tools. Okay. I'm giving that one moment. Sorry. I'm trying to share my screen. Okay, got it. So again, here's a scenario. We're going to go through the PO.DAAC website. Okay. So again, flipping back to the scenario on the first one, Michelle wanted a long time series, gridded global and foundation temperature. So in here, we are going to select for Earthdata. At the PO.DAAC, we have identified GRIS as a collection, so we can easily get to the GRIS data set collection via this link or via data discovery, and so different ways, but I'm going to use this link right here. I'm going to click on GRIS, and it comes back to our data set discovery. Okay. Here we go. Okay, again, on the left side is the faceted search. Now, Michelle wants level 4 data, the blended. So we select that as a processing level. And then we drill down to her temporal range where she wants data that's greater than 20 years. So that's the time span classification, where we select that. And here you notice that there's only one data set. And here comes back one data product or data set, which is the GRIS level 4 AVHR global blended SST. It's a 25 a quarter degree spatial resolution data. From this site, you can click on the title of the data set, and it provides you more information about the data set with these tabs. If you select on the information, it provides you a description as well as all the other classifications about the data set, from the coverage to resolution to latency to what platform sensors it covered, the project, the provider, and so on. In addition, there's a tab for data access, where here, since we are in partnership with NOAA, NODC, we provide a link to their site for they support all the data graded for more than 30 days for the level 2. So we provide all of our GRIS data set a remote FTP access. And here you can see also that we have the OpenDAAC access as well as FTP. We will provide other accesses to the tools so that users can directly go to live access, say, from this page. So we also have the granular file listing, and the granular file listing drills down to the various data files that covers this data set. And again, it provides various links that was shown in the data access. Okay, so that's our way of discovering our data. For Jorge's scenario, what he wanted was a high resolution data set with a long time period of not greater than 30 years, gridded, regional, and foundation temperature. So going back again, we'll select the GRIS data product. And the level 4. And he wants a spatial resolution that's very high. So we're going to select the 1 kilometer or 0.01 degree resolution. And here it comes back with a couple. But what he wants is a time span of around 10 years. And that brings us back to one data set. And when you click on that, it provides the same type of layout for the information for this particular data set. Okay, next, we're going to go through the OpenDAAC. I'm going to access OpenDAAC from this data access. Okay. OpenDAAC, again, has the same directory structure as our FTP. As from my slide, you can drill down to the data set, level into the granule, and we're going to just select one. Actually, I will select a different one. And when you click on this, it comes back with the access form for this particular data set, again, where you can see the time, the various variables for this data set, from time, latitude, longitude, analysis, SST, error, mask, CI fraction, as well as all of their attributes. Now, one can utilize OpenDAAC via subsetting by knowing the indices for the region that of their desire, but they will need to know the indices here, so they would need to do a little bit of math. But it is a great feature where you can just utilize, use your scripts to access only the region that you want, so you don't have to actually download the entire data file. Okay. Okay, next we're going to go and I'm going to show you threads. Okay, again, from my presentation, I showed you a snapshot. Here is our catalog for our GHRSST data products. It's just a selected level 4. Again, the threads support level 3 and level 4 data sets projection. Here, I'm going to show you the AVHROI, which is Michelle's selected data product, and how a data product can be aggregated by time. And so here, again, is the catalog, where you can see the various data access, as well as the various viewers that's bundled in the Threads software. So when I click on OpenDAAC, again, this is an aggregated time series, full time series from 1981 to 2013. You can tell here, because time now is not a 1 value, but rather almost 11,592 time. So if one was to subset this particular data set, they can do it with one pass. They can select the variable of their choice, which is an analyzed SST. You provide the entire time indices, just like so, and then the indices for your latitude and longitude. And what will come back would be a URL that you will use to pass into your script. And that's how you would basically get the entire time series for a particular region. One of the data viewers I want to show is Godiva. It's a web viewer. Coming up. Coming up a little bit slow. Okay, here you go. And what it's doing is it's accessing the entire time series for that particular data set. So here it recognized the title of the data and the variables. And once you select the variable, then it pops a map. And you would have to click on Auto to apply the color scale for the map. And here it provides you the calendar where you could actually create some type of animation you like, where you select your first frame and your last frame. So it's a nice way to visualize the data set before you actually, start using it. So those are the nice features of Threads. Next, I'm going to go over again the scenario before I go into LAS. Going back to the data set choices that we have for scenario 1, which is the AVHR-OI, which is a quarter-degree global grid that spans from 1981 to present, and scenario 2, which is a high-resolution data from 2002 to 2013, which is the level 4 mirror global SST analysis data. Okay. So LAS has this GUI interface when you go into our LAS data server. Here are the buttons. Oh, close it. Here is a button where you can choose a data set, and we have selected data sets for ocean temperature, but we also have various parameter data sets available in our LAS server. But for today, we're just going to go over the ocean temperature and GHRSST. For Michelle's scenario, we wanted the AVHR-OI and analyze SST temperature. And what comes back is the first image map for the first file of that time series. Just going over the interface here, you see that there's an interactive map with controls on top of the map, and the buttons on top are basically controls what you can do for the map that's already provided to you, that's currently provided to you. You can also do plots and time series on the left-hand side. So for Michelle's scenario, we wanted to do an El Nino Southern Oscillation observation in the equatorial Pacific. So we select the equatorial Pacific either by creating a box around that region or using a pre-selected ocean region. And this is what I'm going to use because it keeps the values for the latitude and longitude persistent. Okay, so once that's pre-selected, you update the plot, and it'll provide you a really nice almost high-resolution image for this particular time range. Now, in Michelle's presentation yesterday, she had chosen 1996, 1997, and 1998. So I'm going to do that. It's for December. And I'm going to apply the plot. Oops. Something happened. Okay. So that's 1996. And this is considered, okay. I will pass the mic to Michelle, who will give a description of what you guys will be seeing.
So from yesterday's presentation, I basically showed the 3 different phases of the El Nino Southern Oscillation, or ENSO. And this actual date, what you're actually seeing is something called normal or neutral conditions. So you see the Western Pacific warm pool waters, and in the Eastern Pacific, you actually see this equatorial cold tongue, so a region of cold waters that basically is caused due to easterly winds or winds from the east going towards the west. So that is what you're seeing in this actual animation here. And note too, for the GHRSST product, the temperature displayed is in kelvins. So if you actually wanted to convert this to Fahrenheit or Celsius, that can easily be done by setting the plot options, and you actually do an expression evaluation. You just subtract 273.15 and you would get Celsius. So these are all capabilities that are within LAS. And I'll pass it back to
97.
Oh, and now it's on 97, excuse me. So this is actually showing El Nino, so the warm phase. So basically you're seeing warm SSTs across the entire equatorial Pacific. And the next one that Rosanna is going to show you is going to be La Nina. So La Nina is an exaggeration of the normal conditions or neutral conditions. So you're getting enhanced easterly winds, so enhanced winds from the east. So you basically see that that cold water is much colder than the normal conditions, and it also extends further west in the equatorial Pacific. So these are all things you can do with LAS, looking at different climate phenomena, how it changes over time, etc.
Thank you, Michelle. I'm going to quickly show you how to do a Hofmolar plot. Oh, I'm going to redo this. I'm sorry. It took my view away. Okay, so going back to Equatorial Pacific, I'm going to do a Hofmolar plot for the time frame of 1996 or 95 to 1999. Okay, December. Okay, this is what you would do. You select your date range. But what I'm going to do here is I'm going to change just slightly my value because I've already done an exercise with the actual value that I want to show you. But what I wanted to show you is once you do that, you notice that I've selected about 4 years worth of data here. And that's going to take a while, probably like a few minutes or so. And I don't want to take up that time. So what you would see when you do select that for a Hofmolar plot is a timer. And it also provides you an area, which will be coming up shortly, an area for you to enter your email address so that you can just select that and get a notification when the processing is done. So I would put in my name, and I would say request email notification, or you can wait for it to come back with the actual plot. But I would request, and so now it says that it's going to send me an email. Now I want to show you quickly what it is that you'd see. So here's what I have already done. This is the kind of email that you would get. It's a very, very long URL link. So when you click on it, you would get something like this. And so Michelle will describe to you what it is that we're seeing.
So what you're seeing again, basically what this shows you is over time for a certain latitude over a longitudinal range. So the time is the y-axis, the longitudinal range is the x-axis, and what's plotted is temperature. So as you sort of use your eyes and go up the actual y-axis, you actually see normal conditions. So you're seeing warm water in the western Pacific, so you can think about around 140 degrees east. Cold water is around 100 degrees west in the eastern Pacific. And as you continue that trend upwards, around 1997, I would say in December, it's the peak actually of El Nino, you see exactly what Rosanna showed you in the spatial plot. You basically see that warm water extending across that entire equatorial Pacific. Then it transitions in 1998 into a La Nina. So if you look at the 1998 time period versus 1996, you see again that that cold water extends further west in the equatorial Pacific, representing La Nina. And this La Nina actually goes on for a while. Some people say from 1998 all the way to 2000, 2001. So that's basically what you're seeing from this.
What I've also done was I've done even a longer time series example, which is a span of 20 years for the entire equatorial region, region. So this is actually how it looks like.
So this is, again, just showing a different representation globally, but if you were looking at something like El Nino, you would focus upon that box again, sort of from, I would say, about 180 degrees east to 90 degrees west. And again, you're basically seeing over that 20-year time period all the El Nino, La Ninas, and normal conditions that occurred. And clearly this will continue with the SST records continuing, so we'll gain more insight into how El Nino is represented in the equatorial Pacific and how it changes over time.
Okay, thank you. Now going quickly for Jorge's scenario, which is a scenario 2, what he had done was he had basically done a comparison of 4 different data products to determine that he would require a much higher resolution product to do his studies. So in here, what I'm doing is I'm going to choose the data that we've determined that satisfied his requirements, and that is the Muir Global. Okay, what I'm going to do is he had selected an area off of Peru, so somewhere over here. When you update that plot, it's going to zoom into the area of Peru, and I'm going to change the time frame to 2009 because that's what he had chosen. Okay. Once that's gone in, what I'm going to do is I'm going to bring up the other 3 data sets using the compare function. And the compare function allows me to bring up other data sets in the other 3 blocks here, or bring up other variables within that data file. But what I'm going to do based on Jorge's scenario is actually bring up 3 other data sets into the block. And the way you would do that is so the first block, upper left, is the Muir. So in here, I'm going to select the OSTI data product, and you do that by going into the control and selecting that particular data set. And what comes back, unfortunately, for this version of LAS, it does not retain the region that I've selected here. I would actually have to go ahead and retype the selected region. So I would do that, and then here I would do the same thing to select the AMSR-E data product, and the other one would be the NCDC. So what I've done was I've done this earlier just to save time. And here is actually the 4 data products, if you can see that. Sorry, I'm going to do this. So these are the 4 data products that one can compare. The I here tells you exactly what data set that you chose and the time, and I've made sure that they are as consistently the same time as possible. Okay, and I can pass the mic to Jorge to have him describe what you're seeing.
What you're seeing is the sea surface temperature off the coast of Peru, but you clearly see the cold water that's kind of hugging the coast. Well, that's associated with the upwelling off the Peruvian and Chilean coast. But the one thing that's very interesting about these kind of comparisons, you have these 4 panels, and you can kind of get a quick idea about which data set is smoother, which data set you might want to use for this particular area. But of course, this in itself doesn't give you probably enough information to make the kind of decisions you want to make. That's where you have to end up, looking at other issues like gradients and things like that. But, the nice thing about LAS is that you can actually visualize these 4 data sets in the region that, you're looking at all at the same time. And this is a great example. All 4 of them show very nicely the cold water, the blue cold water that's hugging the coast off the Peruvian, Chilean region because of the upwelling.
Okay. Thank you, Jorge. Okay, going on to the other features of LAS. I need to find my, okay, here we go. Sorry about that. I wanted to show you the other controls. Just go back to the main folder. So going back and selecting GHRSST, I wanted to show you quickly on how to actually do all sorts of things with this particular tool. I'm going to select this area, and with the set plot option, if you can see this very well, you can actually add in contour styles into your plot. Update that. Just like so. In addition, from the set plots, you can change your color fill levels. And what's nice about this is on the very right side, there's these question marks. these are basically help. And so it tells you exactly how you would type in the number for this particular field. Okay. And also, if you need to change, again, like what Michelle had said earlier, if you need to change the Kelvin to, say, Celsius, this is exactly where you would apply the expression. Now, one of the things that we have found out that LAS has a limitation on is on the animate. Unfortunately, with the nature of GHRSST data being so large, the animate is very limited to only a few data sets. So I'm going to skip over that, but I do want to show you that they do have other functions like show values, and what that is it'll actually dump the values for that plot. You can cut and paste, save it. Okay. Also, the export to data desktop application, what this is it basically provides you sample scripts for MATLAB, Ferret, GRADS, or OpenDAAC URL. I'm going to select all, and what you'll see here are excerpts of what you would include in your script to access this particular data set for this particular region and for this particular time. So it's nice that they have this quick tutorial on how to access the data. And in here, you can save as, and again, the select format is NetCDF, ASCII, CSV, or ArtGrid. I'm going to choose NetCDF. You can select more data files here, your temporal coverage, but I'm going to say OK. And what it'll do is it'll actually download the file for you. Unfortunately, I cannot view it. I would bring up Panoply and show you that it's actually projecting only the subsetted area that is shown here. But taking that NetCDF file and bringing it into Panoply or any of your chosen viewer will show you the data. Now the link to here is if you want to share this particular map to a colleague, you simply just cut and paste this and bring it and put it in your email and send it off. And I want to show you once I append it to another tab here, this is what you're seeing. So they're just seeing basically another last call for that particular image. Okay. There's also another time series plot here, line plot. I can show it to you very quickly due to time. When you select one, I'll just select a short, maybe 3 days worth of data. And okay. And when you select that, it basically provides you a point. You can put your point anywhere in the map. And then for those 3 days, or 3 days, when you update it, it will create, since it's a 3-day and the data set is low in resolution, it'll provide you the time series plot. If I make it a longer time frame and update the plot. So I think I've covered up most of the most basic functionalities of LAS that is really nice for science usage, really for verification, validation, for viewing the data set, possibly for analysis as well. But the tool can be used not only for scientific research purposes, but also it's a great educational tool to show features in oceans such as El Nino and La Nina. So I think that is the end of my demo.
Could you show an example map of the Mediterranean?
Oh, a map. Oh, okay. There was a user question to show a map of the Mediterranean?
Yes.
Okay. For what data? Hi.
Let's
Did
just
you
take
see this
grid
one?
status sector, that's
Okay.
fine.
So since I have myself in a time series plot, you want a map, I can either choose Europe here, Okay, or just go straight to the Mediterranean, just like so. And there's the Mediterranean map. Okay. If you decide to use any of our tools, which will be great, if you have any questions with regards to any technical issues, please send us an email at PO.DAAC@PO.DAAC.jpl.nasa.gov. I believe we will be providing any of our contact information in our presentations that will be available through Adobe with the video. Thank you so much.
Okay. Thank you, Rosanna. And now we are going to move to, you have to stop sharing. And we'll move to the polls really quickly. Okay, if everybody could take just a couple of minutes here to fill out these polls, that would be fantastic. After this, we'll move on to the question and answer period. Okay, it doesn't look like there's, well, there's a little bit more activity for the future topics here. I'm going to give it just one more minute and then we'll move on to the question and answer. Okay, why don't we move on to the question and answer period? First, I would like to take this opportunity to thank everybody for participating in the second day of our two-day webinar series. Thanks also for your patience for those that needed to re-register. I greatly appreciate it. I noticed in some of the future topics people were interested in other discipline data products, for example, precipitation and land surface temperature. I do plan to have other webinars available. We will actually put a calendar up here. The next one will focus on Giovanni, which does have a portal not only for accessing and visualizing on the fly ocean color data, but also precipitation data. And so what I will do is I will, keep the participants for this webinar on the list for future events. If you would like to not receive information about future events, please feel free to shoot me an email at the jennifer.l.brennan@nasa.gov. All of that contact information will be sent out to you when the webinars are sent out in a link, so you will have that along with additional information, the question and answers. So thanks again. Why don't we go ahead and take a look at some of the questions here. It looks like many of them have already been answered. Okay. And actually, we can proceed with this verbally rather, since we don't have a huge number of participants today. We can go ahead and proceed verbally unless the presenters object to that. I think that would be a good opportunity for interaction. So the first question was with respect to level 2P definition. It looks like that's been answered by Ed. Were there any further questions on that? Okay. Second question was with respect, okay, Ed's answering now. Is it possible to use Open.DAAC to find all level 2 data that fall within a certain latitude, longitude box, or only swaths that cross one latitude, longitude point?
Hi, this is Ed. I'll answer that question. I was just in the process of typing it, but I'll just verbally give the answer. So the answer is, well, Open.DAAC can't do that, unfortunately. But we do have this level 2 subsetting technology that we didn't demo today called High Tide. One of the reasons we didn't demo it is we're still in the process of improving it, and one of the features we're going to be added just to do that this user asked for, is to be able to essentially, when sending a space-time domain, extracting all the various level 2 data sets that fall within that particular box and time range that user selected. So that particular feature that we're going to implement in High Tide will be available probably sometime this summer. Thank you.
All right, great. And then let's see here. It looks like the question regarding the High Tide server has been answered. Okay, David. And we showed the map already. Yes, the question and answer responses will also be available to you. For those that have been answered verbally, I would ask that the speakers actually take the time to type in the answers to the questions. So we'll have to go back through both yesterday's webinar and also today's to ensure that that has happened, David, okay? And let's see. And yes, you can unmute your phones and, we can speak. Let's see here. Make sure that everybody unmuted. So it should be off mute.
The conference is now in talk mode.
Oh, good. Okay.
All right, everybody.
Hello, testing. Can you hear me?
Yes, I can hear.
Okay.
Well, we may have a little bit of echo. That's the only downside. Okay, so it looks like all the questions have been answered as I'm going through here. Does anybody else have any questions?
Yeah, I think Michelle, I had a question for Michelle about the other data sets. She asked me about High Tide, and she asked for any feedback on data sets would like to see. And so is AMSR data, there's an AMSR 2 satellite up there now. Is that stuff going to be available? And for instance, I know I'm interested in brightness temperature. Most of the folks are interested in ocean applications. I'm interested in the sensor technologies. So I look at brightness temperature, and I get that from National Ice and Data Center in Colorado.
Right.
you going to try to duplicate that or supplement that or
So let me try to tackle that. So with regards to GHRSST, I mean, GHRSST so far has only been focused primarily on level 2 and above. We have in our science team meetings in the last few meetings or so discussed, the possibility of distributing level 1, radiance data such as you're interested in. But there hasn't been like any formal adoption or process to do that yet. So I guess it's future work that we're intending to do at some point in our project.
Okay.
The answer to data. So that's a little bit of a strange animal right now. Perhaps it'd be best for you to contact me offline. But I can say the Japanese are producing the answer to in GHRSST format. But for whatever reasons, they have chosen to just distribute that data themselves and not to put it in the so-called GHRSST pipeline, so it goes to the PO.DAAC and then the NOAA NODC.
Right.
So there's, for whatever reasons, that's the way they have chosen to distribute that data.
Thank you.
But if you can contact me, too, for the details of how to access that data, that'll actually motivate me because I actually haven't gone out and played with that data myself yet.
Well, and Q, to answer your question, so right now within High Tide, we have the GHRSST MODIS Level 2P from Aqua, as well as from Terra, AMSR-E, ASCAT, QuickSCAT, and also JSON-2.
Wow.
So it's in our plans to try and get all of our Level 2 within High Tide, but having priorities on data sets is key. So if there is a data set that we have in PO.DAAC that you want in High Tide, as soon as possible, please let us know because that will set our priorities of data sets coming in.
Thank you. Thank you. Is that globe? Is that a globe? That globe available that you showed us before? Is that available?
Which one? Globe.
You show the global temperature on high tide. That's sort of live, or?
I don't think we're following you, David.
One of the slides showed something on high tide, which showed the globe, the sea surface temperature, and a sort of like near real time or something.
Isn't that?
Oh, you're referring to as the State of the Ocean tool, SOTO. SOTO
Okay,
is available directly from our web portal as well.
Okay, now let me ask you, I work with a museum on developing, we have a climate center display. We have a live kiosk now. We're going to access the internet. I wanted to have that on access to that through a live connection.
Oh, that would be fantastic. Yes.
Yeah. Okay. Who should I contact if I have more? I don't want to take up everybody's time. Who should I contact if I have more questions about that?
You can contact me and Rosanna, and I'm guessing, Jennifer, at the end of this, you're going to be giving our contact information, correct?
Okay, I just want to call I don't want to call the wrong person for the right question. Okay.
Well, if not, I can write you offline, David.
Thanks a lot. Okay, bye-bye.
Yes, I will follow up with all the participants. I don't have a slide prepared for the webinar, Michelle. However, I will follow up with the participants with not only the recording, but also the contact information.
Right.
The recording will be posted no later than Monday. I did have a question about that. We do need to go through yesterday's recording in the beginning captured logistics type difficulty discussion, so we may we'll have to go through and listen to the recording itself and make sure we've captured the poll information as well as all the questions. And we'll need to do that before we send it out. Let's see. So the next question. Okay, is it possible to replot the SST 1 kilometer data from a small area like the U.S. Virgin Islands using Google Maps? Speakers? Speakers?
The conference is now in silent mode. The conference is now in talk mode.
Michelle, did you guys hear me?
Yeah, we hear you, but which question was that from what participant?
It's Adolfo Gonzalez. Is it possible to replot the sea surface temperature 1 kilometer data from a small area like the U.S. Virgin Islands using Google Maps?
Yeah, so going back to last, when you do select your region, you can actually, there's a button at the top of last. I can't show it to you here, but there's a function on top of last where it says Google Earth. you select that, and it'll actually create a KML file for you to download. And once you have your Google Earth application from your desktop, you then just feed that KML file, and that should be able to, bring over the image. So that would be through the live access server.
Okay. Are there any further questions?
I'm fine, thank you.
Okay, so I think we will go ahead and end the webinar. I will be sure to send out a link with the audio recordings and questions for both days' webinars, yesterday including today's. That information will include contact information for contacting the individuals as well as the Physical Oceanography DAAC's User Services Office. That's always a good bet for getting a question answered regarding one of their tools or one of their data products, in that they do have an expert for all of their data products, your near surface winds, your sea surface height, sea surface temperature, etc. Okay? So thank you so much for joining us. It was great to have you.
Thank you very much. It was very, very helpful.
Okay, well, I'm glad to hear that. So even despite the few bumps here and there, it turned out well, I think.
Okay.
Thank you.
Super.
Thank you.
Thank you.
Thanks very much. Bye-bye.
Okay, bye-bye.
Bye-bye.